is a continuation of our study of proportions in relation to equations. So we're going to do section 3.2 on rate of change and slope today. And this will be broken into 3 separate videos. The first one, we're going to go over rate of change from tables. The second video you're going to see is using rise over run with graphs. The third video will be using the slope formula given a graph or a table. The lesson essential question will be, how do you find a rate of change or a slope? The vocabulary words which we will be going over in this first video are rate of change and slope, which are actually the exact same thing as you're going to see later on. By the end of this lesson, you should be able to find the rate of change or slope given 2 coordinates, which will be in the form of x and y, given a table or graph using the rate of change, rise over run, or the slope formula. You will be summarizing this lesson in a foldable at the end of the 2-day lesson, so please make sure that you are aware of all 3 forms by watching each of the videos. All right, here we go. Okay, vocabulary. Rate of change is the ratio of y to x, and this should sound really familiar because in 3.1 we were finding the ratio of y to x with tables. Again, rate of change is also known as slope, so they're the exact same thing. And because they are the exact same thing, they can be represented by k in the equation y equals k times x. So we actually were already using this concept, just not putting a name to it. Here's an example of something we've already done. Again, please remember that the rate of change equals the constant of proportionality, which in essence, again, is finding k. And k is called the slope. So in the example, as you see, we have x and y values. Y is feet, and x is represented by yards. So just like we did in lesson 3.1, we are finding the rate of change. The rate of change is what is happening each time that we are moving up the line if we were to graph this. So from 1 to 2, the change is +1. 2 to 3, the change is +1, and so on. So the change of x is going to be +1. And the change in y, what's happening is each time we're moving up the line again, 3 to 6, we're adding 3, 6 to 9, we're adding 3. So the rate of change is going to be 3. So we can write that as the ratio of the slope, or k, equals y divided by x, which we did in 3.1, and the rate of change would be 3 over 1, or 3 divided by 1, which is equal to 3. So the rate of change would be 3. Please remember that it is constant, meaning it is consistent throughout. If it's not consistent, it's not going to be not going to have slope, and it's not going to be proportional. Another way you may see this in the book of finding it, I'm just going to show you really quickly, is they'll give you 2 coordinates. So I'm going to circle the 2 we're going to use. Let's use 1, 3, and 2, 6. And they're going to find the rate of change by subtracting the 2 y values on the top and the 2 x values on the bottom. So again, this is representing the ratio of y over x. And 6 minus 3 is 3, and 2 minus 1 is 1. So we're still getting the same answer, because 3 divided by 1 is 3. So again, these are the exact same, it's just a different way of doing it. It's a really different